Hey guys, welcome back. So today's lecture is going to be on the pieces of evidence for evolution that prove Darwin's theory of natural selection to be true, or provide evidence to evolution by natural selection. So um, the first piece of evidence, oops, sorry guys. So the pieces of evidence that support evolution include the fossil record, which kind of shows that change over time, that it wasn't just a sudden change in these organisms to make them what they look like currently, um, but more of a gradual change, little changes over a course of thousands, millions of years. We're also going to look at the anatomical record, which includes comparing body structures. We're also going to be looking at the embryology, like the development of the embryos, and how there's a lot of similarities between related organisms. We're going to look at the molecular record, which includes comparing protein and DNA sequences between different organisms. So looking at how closely related DNA, our DNA, human DNA, is to a monkey's DNA. And that is, again, evidence to the fact that we're very closely related. Whereas if we compared our DNA to a reptile's DNA, it would be a lot more different, which indicates that we're less closely related. And then another piece of evidence is, of course, artificial selection. Oops, sorry guys. Which is evolution caused by humans. So, first the fossil record. So the fossil record is, again, fossils are these preserved body structures of these prehistoric organisms, dating back to billions of years ago to most recently thousands of years ago. So we find these fossils in layers of rock, and these layers of rock are covered over and over and over again over a course of millions of years, creating these layers, and therefore we find a fossil towards the top layer, we know it's more recent, whereas if it's toward the bottom layer, it's a lot older. So it kind of creates this record over time. And so these fossils show kind of a series of organisms that have lived on Earth, and we can kind of estimate how old they are or how new they are based on the layer that we found the fossil in. So they tell us a lot of stories. We know the Earth is very old. We know it's about 5 billion years old. We know life is old. We find evidence of life about 2 billion years ago. And we know that life has changed. It certainly has not been the same since 2 billion years ago. So when we look at specific examples, first one is the evolution of birds, looking at fossils. So the most famous fossils ever that was found was the fossil of what we call the Archaeopteryx, which is a bird, as you can see, but it has a lot of similar characteristics to a reptile or a dinosaur, which has led us to kind of believe that this is the missing link between dinosaurs and birds, meaning that dinosaurs evolved into birds, current day birds. So as you can see, this is a lot of similarities to a reptile, but it has feathers. Another example is the evolution of a land mammal to current day ocean mammals. How did these ocean mammals evolve to live in the ocean the way they did? Like when we were looking at this, it was kind of a joke to create this sketch of this kind of in-between of this land mammal, a hunter, to this current day orca or whale. And at the time, it was kind of a joke, but in reality, it was almost true. And we found fossils to kind of back up that this structure kind of slowly evolved. As you can see, we have like almost modern day dog, very similar to a dog. It's a predator, and as it lived closer and closer to water, it developed more and more adaptations to water, and the ability to swim in water. And over time, millions and millions of years ago, we now have evolved into very successful ocean carnivore in the orca whale. Other evidence for evolution is the evolution of fish to land mammals. So how did fish necessarily evolve, and fish in the ocean evolve to um, walk on land? And most recently, in 2006, we found this fossil, this tetrapod that has 4 limbs, and that's why it's called tetrapod, that kind of provides an evidence to what exactly happened to make that transition from land mammals to, or sorry, from ocean fish to current day land animals. Okay, so that was fossil record. Now we're going to look at what we call the anatomical record, so looking at structures of organisms and how the structures are related. So they may look different on the surface, so humans, cats, bats, whales, they may look different on the surface, but they're actually related to each other, fairly closely related to each other, because when you look under the skin, it shows a lot of similarities. So when we look at bones, these are what's called homologous structures. So if we look at the arrangement of the bones of each of these organisms, so we see a human, a cat, a whale, a bat, all mammals, but if we didn't know they were mammals, they just were blind, and we just looked at these without any knowledge before, we could see that there are similarities. The functions of the limbs are different. Human hand is used for grabbing, cat is used for running, whale is used for swimming, and the bat's used for flying. So different functions, but the structure of them is very, very similar, the arrangement. The bones are different sizes, but if you look at the arrangement of the bones, all very, very similar. And this is evidence. This is what we call homologous structures. An important term for you guys to know. And again, this is evidence for evolution. So again, different functions, but the bones are arranged the same. So like I said, homologous structures, important term for you guys to know. It's definitely going to show up on your test, so you should definitely know that homologous structures are structures that came from the same origin, so they're closely related organisms. So same structures, but they have different functions. Also, another example would be like development in embryos, which we're going to look at in a little bit. But the main point of these homologous structures is that they are the same structure on the inside, but different structures, or sorry, different functions on the outside. And again, this provides evidence of a common ancestors between two organisms. So when we look at the bat, the whale, the cat, and the human, all similar structures, different functions, but similar structures, that provides evidence to show that we all had a common ancestor, whatever it was. Now, there's another type of structures you don't want to be fooled by, where they have the same function, but different structures. So, example, a hawk and a dragonfly both have structures, wings, that are used to fly, but the structures are completely different, which is an indication that they're not closely related. So, same function, but different structures. And again, this indicates that they have a different origin and no evolutionary relationship. Another example of analogous structures would be aquatic mammal and aquatic vertebrate. So dolphins and fish, they look very similar. They have that streamlined shape because that streamlined shape in the water is very successful. But if you look inside, it's very different. The structures, the bone arrangement are different, and that indicates they are not closely related, even though they look fairly similar. Another example, another concept, this concept of convergent evolution, where you have this evolution of these organisms to have the same function. So these structures have the same function. All these structures are used to